Hello and welcome back to Aerospace and Mechanical Lab 2. Today we are going to discuss the fifth lab of the Aerospace and Mechanical Lab 2 series. We are essentially going to give you a demonstration on how to use ANSYS to run the lab. Right? I am using the lab computer, so this is basically going to be the same experience as you will have in the lab itself. Right, the first thing we want to do is to open the workbench, which is going to be the workbench that is given to you by the ANSYS software. It will take a little bit of time for the ANSYS to open up, especially if this is the first time you're opening up ANSYS in your account on the specific computer that you're using. And when it's opened up, we are going to, have a better discussion about different parts of ANSYS. So this is your workbench. This is where you create the schematics of your project. This is where your toolboxes, with essentially all of the components that are included in ANSYS, incorporated in ANSYS for vibration analysis, for fluid analysis, for structure analysis, essentially any type of analysis you have is included here. Right? Today we are going to learn how to do a structural analysis. Okay. So, a static structural, we already have a static structural module available to us, but we can actually go to the components right here and create this module from scratch. This is not what we want to do. We are just going to press the left mouse button and drag the static structural module right here. So you can see the first option is the engineering data. If you double click on this, it will open a tab in which you can actually change the material you're using or change the specific data about the material. The material we have right now is this engineering steel. We can change it using the database we have, the ANSYS has, or we can change the values right here. We can change the density, we can change whatever we want to change in ANSYS. Well, we are going to leave this as is. We are not going to change anything right here. Next step is building the geometry. If you right click on your geometry option, it will give you three different software. It will choose the discovery software by default, but there are other two softwares. SpaceClaim is very similar to Creo, and the one we want to use for this lab is called the design modeler. So let's select the design model. Let's open it up. Any of these permissions you cannot allow them because you don't really have admin access to any of the lab computers. Okay, we are ready to create the geometry. To create the geometry, we essentially have opened the design modeler. We are going to you set the units, first of all, to millimeters right here. On top it says meters, centimeters, millimeters. You want to do millimeters. And then we want to create a sketch in our XY plane. We can go to sketching right here. Again, we want this to be in XY plane, so I'm going to click on this Z axis. This will give me the XY plane, and I am going to draw a rectangle. Right here, there is a rectangle tool. I'm going to start from 0, 0 right here. As you see this P option that pops up, means that we are at a specific point. The C option that you see pops up, it means that we are on a specific axis or line, right? So we are going to start from the 0.0 and then create our rectangle. Again, you see the scale is given to you down here Obviously, we want the rectangle to be 200 millimeters by 20 millimeters. And should be done. So we don't really know what the height right now is. What we're gonna do is going to dimensions right here, and we can either choose general or horizontal or vertical dimensions. That doesn't matter. I'm gonna click on the line that I want to know the dimension of, and then there are my pen outs. This is going to be named H1, and the same thing for the other one, V2. So H1 is supposed to be 200 millimeters, so I'm going to change this to 200, and V2 is supposed to be 20 millimeters. So I'll change this to 20 millimeters. This is my sketch. This is what we want to have, and this is what we have. Okay, and then we are going to hit generate. We're going to go back to modeling, and of course the next part is to extrude this to create a three-dimensional geometry. I am going to select all of this. You can just drag them, hold on to the left mouse button and drag it on all of the sides, and then hit apply here. It will choose the sketch. If you only choose one of the sides, it will also choose all of the sketch as well. So I'm going to hit generate, and there we go. We have our extrusion. I forgot to change this depth. Actually, right, I should have changed this to 20. Let me redo this and hit generate again. And right now I have my beam. This is going to act as our cantilever beam, which is 200 millimeters by 20 millimeters by 20 millimeters. We have what we need. We have one part, one body right here. This is a solid body. I'm going to close the design modeler and go to the next step. Next step would be to go to modeling. This is where we actually mesh our system, meaning that we are going to divide the whole system to smaller elements, so our software can solve the problem in those smaller elements. In the lab memo, this section is called mesh instead of model. And that is going to be true for computational fluid dynamics lab that we will do next week. But for now, it is only called modeling. Same thing. It's the same scenario. You want to make sure you actually understand that this is going to be the exact same thing. Okay, let's go. I think it looks like our geometry is imported. This is our geometry of interest. This is a solid. This is what we want. The material is a structural steel, and we don't really need to worry about the coordinate systems. We have the mesh right here. The meshing, we have a lot of options with meshing. If you right click on the mesh, you can actually control the type of element you're using here. The type of element, let me select this and apply this here. We can go from automatic right here to tetrahedrons to hex dominant. This is essentially triangular and structural, and other types of mesh. I'm going to go with hex dominance, right? And you can actually create the mesh up to this point by hitting update. This is the mesh that is created. Can we change the size of these elements? The answer is yes. You can either go to insert and choose sizing right here. There are a lot of other options that we are not going to go over, but essentially the type of elements you have a lot of control over. Or if you're only interested in changing the size, you can come here and change the element size right here. We don't really need to change the element size for this demonstration, but it's not a bad idea to go smaller in mesh size anyway. So we have our mesh ready. The next step would be to set up the problem. We can either close this program and I'm sorry. I'm doing this on a Mac, and this is a remote connection to lab PCs. That's why we're having these issues. But we're there again. I can either close this program, this specific program, and go back to setup right here. It will open the same menu that I have right here, right? Or I can keep doing what I'm doing in this program. This only applies to this lab. For the next lab, you definitely need to go to a different software after meshing. And we're going to learn more about the meshing in the next lab anyways. Okay, so let's go to a static structure analysis. We essentially have two things that we need to do here. We need to apply a fixed support at the end, at one of the ends or this end, and we need to apply a load at this end. Okay, let's do that. You right click on the static structural. You can apply a lot of different things. See, this is a fixed support as we want it. The only thing we really need to do is to change this, choose this edge and hit apply. This is going to be our fixed support. And then I'm going to come back here, insert a force. Force is going to be inserted at this edge. This is going to be a vector, of course. We can change the type of force we're applying. We can change the magnitude of force. It says defined by vector or defined by components. We want to define it by components because we want to apply the force in the Z or Y direction. We don't want it to apply to the, we don't want a compressive or tensile load right here. So the X component will be 0 newtons. The Y component I'm going to keep 0 as well. The Z component I'm going to change to 1,000 newtons. I actually, in the lab memo, it says I have to do this for the Y component, so it shouldn't really matter though. So negative 1,000 newtons. Okay. And we have created the setup that we need. The only thing we really need to add here is the solutions that we want to see later on. So the solution I want to see, again, right click on the solution, deformation. We can do total deformation. We can actually do directional deformation as well. We can select the geometry if we want, but we only have one geometry, so that shouldn't really matter. We can do the von Mises strain, also the von Mises stress. We can actually do maximum principal strain, maximal principal. There's a lot of options here. We can do a strain energy analysis and a lot of other options. But for this lab, the total deformation, based on the lab memo, total deformation and a stress and a strain should be fine. Okay, so we are ready to run the simulation. You only need to click solve right here, and we'll start running the simulation based on our specified setting. Okay, simulation is ran. I'm going to click on total deformation. So we see, based on our results, we see the maximum deformation. This is our bent beam right now. We have applied 1,000 newtons of load in the negative Y direction, and we see the maximum deformation in this location. We have the value, we have a value for maximum deformation as well. Directional deformation, essentially the amount of deformation you have at each point. We have a lot of compression here, we have a lot of extension here. That is what the directional deformation is. Then we have the stresses, strains, and stress right here. These are the von Mises, strain and stress. So, and for your lab memo, you only need to take a screenshot of all of these steps and report the values for the maximum strain and maximum deformation. That will be it for today's lab. And I hope to see you for the next lab right here. Have a good weekend.